Hello class, welcome to this lesson on 7.4, graphing sine and cosine functions. So we're going to talk about using technology to graph the sine and the cosine function. We're going to be identifying key features of sine and cosine functions given the graph or the function. And the vocab for this unit includes the amplitude, frequency, midline, period, and periodic function. All right, the essential question is how can you identify key features of functions? So that's the main goal of this lesson, being able to quickly make a quick graph of the sine and cosine, as well as identify some key features. So what we're going to introduce to you first is the sine. How does a graph of the sine function actually look like when you put it on a graph? Okay, so notice that the general form of the sine is given by f of x equals a sine of b times x minus c plus d. Okay, so you have the sine function, that's the main part of the function, and you have these letters a, b, c, and d, and those represents different types of transformations. Okay, we'll actually talk about what the a, the b, and the d stand for, and then in the next lesson we'll talk about what the c stands for. Okay, so first off, remember that in the unit circle, the sine represents the y coordinate, and the cosine represents the x coordinate on the unit circle. Okay, so what we're going to do is we're going to actually do a graph. So let's go ahead and get started. So let's suppose that you started at 0 degrees. Then the y coordinate at 0 degrees is given by 0, right? Because the coordinate is 1, 0. So therefore, the x-axis here is the angle in radians. Okay, so that means that at 0 degrees or 0 radians, the y coordinate is 0. Okay, so therefore at 0, 0, we have a coordinate. Okay, so now the next angle that we're going to look at is 90 degrees or pi over 2. You got to get comfortable with radians here because we're going to be using radians a lot. From here on out, it'll be mostly radians. Okay, so you got to kind of get used to that. So the next coordinate is when you hit 90 degrees, pi over 2, your y coordinate is 1, given on the unit circle. All right, as shown. Now, if you go 180 degrees, or pi, then your y coordinate is going to be 0. So the coordinates is going to be pi and 0. The fourth point on the unit circle, and notice that we're traveling counterclockwise on the unit circle. Let's go, oops. All right, so the fourth point on the unit circle is given by 3 pi over 2, and then the y coordinate is -1, and then if you go to the fifth coordinate, you have 2 pi. You're going back to the full circle, which we know is 2 pi, and the y coordinate is 0. So you can see that there's some sort of pattern here. Let me go back to the previous one. So that's the fourth coordinate right there at 3 pi over 2 at -1, and then going back to 2 pi. All right, so those are your coordinates. So now if we go ahead and connect those with a curve, we get something that looks sinusoidal, right? Something that looks like a wave, right? So the sine and the cosine function actually look like waves when you draw them. All right, let's go ahead and describe some features of this. So first off, you have a maximum, which is the peak of the curve, right? The biggest part of the curve, the highest part. You have your minimum, which is or otherwise known as your trough, and that's your smallest part of the curve, your lowest part. Now you have what is called the midline. So the midline is the middle line, and it's halfway between the maximum and the minimum. Okay, so to find the midline, you simply take the maximum and the minimum, add them together, divide by 2. So basically, you're just taking the average of the maximum and the minimum, just averaging those out. All right, another way to find the midline is by looking at the d coordinate, because remember that, and I'll write it here. remember that we said that the generic form of sine is something that looks like this. So a sine b times x minus c plus d. So if you look at this d, that actually tells you your midline. Okay, so if you know the equation, you can use it to identify the midline. All right. The other feature that I want you to know, the other key feature, is the amplitude. The amplitude is the distance from the midline to the maximum or minimum points. So the amplitude here, I'm going to zoom in on that. To find the amplitude, you take the maximum y, the coordinate for the maximum. This is the y coordinate right here. So I'll go ahead and label this. This is the y coordinates for these guys. Okay. So you take the y coordinate for the maximum minus the y coordinate for the midline, and that gives you the amplitude. So in this example, the midline is 0, y equals 0, or the x-axis in this example. So, and then in this example, the maximum is 1. So therefore, the amplitude is 1 minus 0, right? Which is going to give you 1. All right, and notice that that's the distance from peak to midline or midline to trough. All right, the amplitude is also given by a. So again, writing the equation, a sine b times x minus c plus d, the a actually tells you that it's the amplitude. And in this case, we're just drawing the sine of x, and so there's an invisible 1 there, right? So therefore, amplitude is 1. It's another way of doing it. All right, the other feature is the period. So the period is the length of one full cycle. So it's the distance from peak to peak, trough to trough, or just from the initial to the final points on the thing. As long as you're going from initial to final point, where after that point it begins to repeat, that's one full period. So it's the length of one full cycle of the graph before it begins to repeat. So to get that, you take the ending value minus the initial values. So you subtract those two values, the x coordinates for those values. And then another way of doing it is to take a 2 pi and divide it by b. So remember again, and I'll write it again just so that you can get constant exposure to this. This is the general form for sine. If you take the b here and you do 2 pi divided by that, then that's going to give you the period. So in the case we're drawing right now, our function is sine of x. That's our function right now, is f of x equals sine of x. So therefore there's an invisible 1 here, so a is 1. There's an invisible 1 here, so actually b is 1. So it's 2 pi divided by 1, which is 2 pi, which is why we got a period of 2 pi. And the d is actually 0, right? If you compare those two forms. All right, so you can also tell that it's 2 pi because this right here is my ending x coordinate. This is my ending x, or my initial x coordinate. And then we know that 2 pi minus 0 is 2 pi. So two different ways of doing it. If you have the graph, you can do this. If you have the function, you can use this. All right. So that's the period. Now the last feature that I want to discuss before we hit another one and another example is the frequency. The frequency is simply the reciprocal of the period. So if you have the period, you can just do 1 divided by that period, and that gives you the frequency. Another way of doing it is doing the reciprocal of the formula that I gave you earlier. Remember the formula for the period was 2 pi over b? Well, if you do the reciprocal of that, that gives you the frequency. So basically what this represents, and this is important, is how many cycles do you have, how many wave cycles do you have within a specific period of 2 pi. This is key. Has to be a specific period of 2 pi. So how many cycles do you have within that 0 to 2 pi mark? Okay, within 2 pi basically. So how many wave cycles do you have? So if you have 2 wave cycles, if you have 2 waves before you hit a length of 2 pi, then that's a frequency of 2. All right. So you can imagine the more waves you have, the higher the frequency. All right. So notice that I went ahead and extended this another period. And this is because this wave goes on forever. And like we said, that it repeats. So it repeats forever. And the unit of repetition is the period. All right. And notice that for the black graph, we traveled counterclockwise. For this blue graph, we actually traveled clockwise. So if we travel clockwise, we're going actually, kind of backwards here, right? We're traveling this way if we're going clockwise. And we're traveling the other way for counterclockwise. But regardless, it's the same graph. It's just mirrors on the other side, right? All right, so that's another thing that you should know. So let's go ahead and quickly draw the cosine. The cosine is the same deal, but remember that the cosine is the x-coordinate. So therefore, if you do the x-coordinate, starting at, actually, let me go ahead and fix that. There you go. So starting at the 0 degrees, we know that the x-coordinate is 1, right? So therefore, when the angle is 0, the x-coordinate is 1, and therefore I'm at the 1 instead of at the origin. Now, when the angle is 90 degrees or pi over 2, the x-coordinate is 0. So therefore, we're down here at the 0. And then when we hit 180 or pi, the x-coordinate is -1, and therefore we're down here at the -1. When the angle is 3 pi over 2, the x-coordinate is 0. And then lastly, when the angle, and I'll zoom in on this, when the angle is back to a full circle, 2 pi, the x-coordinate is going back to 1. And therefore, we start to repeat there. So that's one whole period. Let's go ahead and draw the graph. So that's how the graph of the cosine looks like. That's the unit of repetition for the cosine. So that's one full period of the cosine. So let's go ahead and extend it to one more period on the other side, traveling clockwise this time. And we have that. Again, looks very similar to the sine. But this time it starts up instead of starting at the origin. All right, the midline is the purple line in the middle. And to find it, you take the average of the peak and the minimum, the maximum and the minimum, by adding them and then dividing by 2. So we know that the peak is 1, the minimum is -1. So then 1 plus -1 is 0. 0 divided by 2 is 0. Also, you can use the d coordinate, and that will also tell you the midline. And then we find the amplitude, which is the distance from midline to peak. So let me zoom in on that actually. The distance from the midline to peak is a unit of 1. You can also take the y-coordinates. So the y-coordinate of the maximum is 1. The y-coordinate of the midline is 0. That's the purple line. And then 1 minus 0 is 1. And then the period is, again, going to be 2 pi because the unit of repetition is between 2 pi, the x-coordinate of 2 pi there. Let's go ahead and fix that real quick. So I apologize for the frozen state there. But the x-coordinates here are 2 pi and 0. That's where it begins and ends. So 2 pi minus 0 is 2 pi. All right. And then lastly, the frequency, you're just going to do you're going to flip the period. The symbol for the period is t, that capital T, by the way. So this is the same thing as 2 pi over 1. So if I flip that, it becomes 1 over 2 pi. Very simple to do the frequency, just flip the period. All right, so I'm going to show you a quick demonstration, basically an animation of what we did, just to kind of summarize the sine and the cosine, okay? So let's go ahead and get started on that. This is on Desmos. So we're gonna, when I show you to graph, we're gonna actually use Desmos to do the graph, okay? All right, so let's zoom in. Okay, so let's zoom in on this. real quick. So this is my unit circle. Yeah, let me zoom in on all of this. Okay, so now that we got our unit circle, we're going to go ahead and graph the sine first. So remember, the sine is the y-coordinate. So notice that as I'm traveling around the circle clockwise or counterclockwise, I'm drawing the sine. So this is the relationship between the unit circle and the sine. As you can see, as I'm traveling around, I get the entire graph. Okay, so that's one full period right there. All right, so that's how the sine looks like. Then we're going to go ahead and do the cosine. Okay, so now you know that the sine kind of looks like a snake. It kind of goes sinusoidal like that, right? So now let's go ahead and do the cosine. The cosine is the x-coordinate. So let's start there. So now you start up top. You're working your way around now. So the cosine looks more like a U shape for the period, right? And then it just and then you repeat after that. Okay, so it starts out U shape, whereas the sine is more like the snake. It starts out, it does sinusoidal more. All right, so that's the animation, how that looks like. So let's look at an example, because I want to make sure you guys know how to graph. So what you're going to do is you're going to go on Desmos.com or the Desmos app, and that'll help you graph, sine and cosine functions. That's all I want you to know how to do. Is just to be able to graph using technology. So you're going to be using Desmos. So let's say we want to graph this function right here, 3 cosine of 4x. So you're going to use Desmos to graph. So let's go ahead and pull up Desmos. You're going to do it on the web. Just type desmos.com and then graphing calculator for Desmos. And we want to, our goal here is to graph 3 cosine of 4x. Okay, so we're going to go ahead and do that. So 3 cosine of 4x. Let's go ahead. Hold on a sec here. All right. So go ahead. Let's go ahead and type it. Sorry about that. It was kind of glitching here. So we got here 3 cosine of 4x. You just got to type that in. That's all. All right. So now we're going to go ahead and get our graph. All right. There you go. So there's our graph. And what you can do is on Desmos, you can actually, the good thing about Desmos is that you can actually control some of the settings here. So if you go to this little icon, this little wrench icon, you can control you could say, okay, well, I want it to go from, let's say, -2 pi. You could type in -2 pi to 2 pi. You can adjust your your x-axis and your y-axis. So that's something cool that you could do if you want to do that. All right, but this is how our function looks like, and then you can go ahead and trace the curve. So we're going to go ahead and trace this. I'm going to trace this down below. Okay, so just wanted to let you know that that's something that you can do. You can go on Desmos and get that done. All right, so this is a snapshot of that curve from Desmos, and this is how it looks like. That's all you got to do to be able to graph sine and cosine, folks. That's all. You just use Desmos and then jot down the graph. All right, so here we have actually multiple periods of the graph. Okay, so since it is a cosine, remember it starts there normally, and then it does this, and that's one repetition of cosine. After that, it repeats again and again and again. So what's the midline? The midline here is the middle part right here. Okay, And so we know that the maximum here, the maximum y-coordinate is 3. So that's what it looks like from the graph, right? So it looks like the maximum is 3. And the minimum is y equals -3. Okay, so that's the minimum y-coordinate. So if we want to figure out the midline, we just do 3 plus -3 divided by 2, which is equal to 0. So that's how we get that from the graph. So that's our midline. So my midline is y equals 0. So the amplitude is the distance from the midline to the peak or the midline to the trough. And then we know that that distance is 3. Okay, because it's going from the 0 line to the 3. So it makes sense. So it's basically 3 minus 0, which is going to be 3. And then the period is the distance for the length for one cycle. So right here, this is one cycle. After that, it repeats, right? So after that, it begins to repeat. So what are the x? Let's subtract the x coordinates. So the x coordinate where the cycle ends is pi over 2. The x coordinate where the cycle begins is 0. So basically it's pi over 2 minus 0, which is pi over 2. Okay, so that's how you find the period. So now we have pi over 2 is my period. Another way of doing that is we know that our function is cosine. What was it? It was 3 cosine of 4x, right? So another way of doing it is we can use the formula. So remember, a cosine bx minus c plus d. Well, we can see that cosine is 4, or b is 4, sorry, and then a is 3. So the amplitude is 3, and b is 4. So that means my formula for period, remember, was 2 pi over b. But we know b is 4, so we have 2 pi over 4. And 2 pi over 4 is the same thing as pi over 2. So there's my period. There's another way of doing it. I'm showing you 2 ways of doing it. To do the frequency, we do 1 over t. And so it's 1 over the pi over 2. So you just got to flip that, and you get 2 over pi. All right, so that's my frequency. 2 over pi. So now let's do an example. So what happens if we have a graph and they want us to determine the key features? You're going to do exactly what I did here. If they just give you a graph, no function or anything like that, you don't know if it's cosine or a sine. Well, first off, how do you tell if it's a cosine or a sine? Well, notice here that this curve actually starts here, and then it goes like that. And then after that, it repeats. Well, that looks a lot like the sine. Because remember, the sine kind of looks like that. We're at the origin, right? It kind of looks like the snake. And then the cosine starts up here, and then it does the U, right? So that's cosine. So this kind of looks like a sine. So if I were to ask you, is this a sine or a cosine? Well, it's a sine based on how it looks, but it's just kind of shifted up. Okay, so let's go ahead and find the midline. The midline is halfway between the peaks, right? And peak and the trough, halfway between the maximum and the minimum. So that's my midline. How do we calculate that? Well, we know that the maximum y-coordinate is 5. Okay, so that's y equals 5. The minimum y-coordinate is 1. So y equals 1. So we just got to subtract those numbers, right? We just got to average those two numbers, 5 and 1. So we got to average them. So for the midline, it's going to be y equals 5 plus 1 divided by 2, which is 6 divided by 2, which is 3. So it's y equals 3, which we can kind of tell based on my graph. It's y equals 3. Now the amplitude. The amplitude is the distance from the midline up there. Well, what is that distance? Well, this is 3, and that's 5. So the distance is 5 minus 3, right? Which is 2. All right, so that's my amplitude. So it's 5 minus 3, which is 2. All right, and then my period is where we're a 1 unit of repetition. So 1 unit of repetitions from there to there, right? So the x-coordinate for there is pi. The x-coordinate for there is 0. So we have to do pi minus 0, which is pi. So my period is pi. So that's my capital T. And then my frequency, you just got to flip it. So F equals 1 over T. So it's just 1 over pi. All right, and those are my key features. That's all we got to do. Nothing more, nothing less. So now let's do one more. We're going to do one more, a couple more examples here. So example 3, without graphing, determine the key features of the following function. Okay, so let's go ahead and recognize what this is looking like. So this is y equals a sine bx plus c. And I'm kind of covering it right there, but there's my function. So if we compare the and there's of course here an x minus c. So I forgot to include that. X minus c plus d. I forgot about the c part. So there's my function. Well, what is a? A is 5. What is b? Well, if you compare these, b is 4 pi. And c, there is no c there, right? Because there's no c in parentheses with the x. X is just x. So b is 4 pi. C is nothing. We don't have C, right? And D is -3 if you compare those. So D is on the outside. All right, so why do we need those? Well, because D is my midline. A is my amplitude, and B helps me with my period and cycle and my frequency. So now that we know that D is -3, that's my midline. Y equals -3, done. Amplitude, A equals 5, done. Very easy. Period. Well, the formula for a period is T equals 2 pi over B. My B is 4 pi. Just plug that in. 2 pi over 4 pi, which is going to be, pi's cancel. It's going to be 1/2. And that's my period. Nothing more, nothing less. And then the frequency, we have to flip 1 over T. So it's going to be flipping 1/2. If you flip 1/2, it's going to be 2. And there's my frequency. And that's telling you that you have 2 cycles for a period of 2 pi. All right, and that's how you do key features for just a function, no graph. The last feature that I want to show you real quick is the average rate of change. It's not hard to calculate. And the formula for the average rate of change is subtract the final coordinate minus the initial y coordinate, and then subtract the final x coordinate minus the initial x coordinate. So basically it's change in y over change in x. Okay, so this is basically y final minus y initial over x final minus x initial. That's how you do the average rate of change, AROC. So if I give you a function and I want you to calculate the average rate of change, well, you gotta figure out what the y coordinates are. So in this example, they said that the function is 2 cosine of 3 pi x. Find the average rate of change over the interval 0, 1. All right, so in this case, this is my this is like my b coordinate, my final, and then this is my a, my initial. So to do the average rate of change, I have to plug in, well, I know that according to this formula, b minus a. So it's going to be 1 minus 0. B is 1 and a is 0, according to the coordinates here. So now what we're going to do is plug in 1 and plug in 0 into the function, and that will give me my y coordinates. So let's plug in 1. So f of 1. Let's plug 1 in for x. So you get 2 cosine of 3 pi times 1. And there you go. So plug in 1 for x. So 3 pi times 1 is 3 pi. So we have 2 cosine of 3 pi. Well, what's cosine of 3 pi? Cosine of 3 pi, according to the unit circle, is -1. if you go back to your unit circle. So we have -1 times 2 is actually -2. So my final y coordinate is -1. Now I got to do my initial. My initial is when I plug in 0 into it, or I plug in a into it. So that's going to be f of 0. So this is my y final. This is my y initial. So if I plug it in, 2 cosine of 3 pi times 0. Well, 3 pi times 0 is 0. So this is going to be 2 cosine of 0. Well, what's cosine of 0? On the unit circle, that equates to 1. Cosine of 0 is 1. 2 times 1 is 2. So this is going to be 2. There you go. Plug those in and you get your average rate of change. So we have -2 minus 2 is -4 over 1, which is going to give you -4. And that's my average rate of change between 0 and 1. All right, guys, we're going to stop there. That's all the key features. We have average rate of change, period, frequency, amplitude, midline, and how to graph it using Desmos. I hope you found this lesson useful. And guys, I'll see you in the next one.